Geotrig, note outline, lesson 16. We're going to talk about complex fractions. We're going to talk about abstract equations and doing long division with polynomials. I'm actually thinking that most of us have done some of this before, so let's hammer it down, get it sorted out so that we can make this a little easier for ourselves. So, complex fraction. What is a complex fraction? It's a fraction that contains more than one parallel dividing line or a fraction line. Okay? So it has more than one fraction in it. So it has more than one fraction line. If you take a look at the example below that we're going to figure out, I'm calling it option 1, you have 2x over 7, which is a fraction, divided by, that's a bigger fraction, of x plus 4 divided by 14. So there are like 3 fractions in one problem. We consider that complex. We don't like it. We got to simplify it. Now, there's at least 2 options here that I am going to say there are, and there's one option that I would prefer over the other. But it also matters what kind of complex fraction we're looking at. Okay? So, I'm not necessarily going to follow the book's rule, in this case, every time. The first rule that says, hey, if I got a fraction divided by a fraction, wait a minute, I can just do what? Multiply by the reciprocal. Sometimes we just say flip and multiply. So I could take this problem and say, hey, I can change it to 2x over 7 times what?
14 over x.
14 over x plus 4. And of course, when you do this, you realize that you've got to multiply fractions. And how do you multiply fractions? Straight across. So you multiply fractions straight across, and then you can simplify. Or wait, we know that everything on top is being multiplied right now, and everything on the bottom is multiplied. Now, be cautious. X plus 4 is its own term, so therefore it is parentheses around those x plus 4. You have to either write them there, or in your own mind, they are there. Because there are 2 options. I can do the multiplication. We'll do that first. Then it just becomes 2 times 14, which is 28x over 7 times x plus 4. Would you guys agree with that? And then what I could do is I could distribute the 7. Now the reason I'm not is because I want to simplify this yet. How many people recognize that a 7 goes into the 28x and to the bottom 7 times x plus 4? So can I divide the top and bottom by 7? Or simplify? And so what happens to the top? It becomes 4x over x plus 4. Can we go further than this? How many people right now want to cancel those 4s?
I don't.
Boom, we take the 4s, out, the x is out, and what do we get?
1.
How about we can't do that? You can't cancel that because the only way canceling works is if you can factor it completely off the top and the bottom. So you can cancel them out, or aka divide them out, which equals 1. So this is your answer. Now let's take a look at if we change it just slightly, going back to this idea that I want to simplify before I multiply. Going back to the idea that we're going to multiply everything on the top, everything on the bottom. Can't I say, hey, I could simplify this by canceling a 7 right here? And that makes it a 1, and this makes it a 2. And can I cancel anywhere else? No, the 2 and a 2 are on top, so they won't cancel, they'll combine. So we are done there, and then 2x times 2 is 4x over 1 times x plus 4 is x plus 4. These are the same. One, I simplified before I multiplied. The other one, I multiplied, then simplified. Both okay. One is usually generally easier than the other because it gets smaller numbers right away, and that's simplifying before you multiply. That's the one that I am going to demonstrate and show you guys as much as possible first. Okay? Any questions on that? Flipping and multiplying, not that big of a deal until you get to a problem that looks like this.
Oh,
Option number 2.
Show me now. Okay. Whoa.
Now, moving on to this one. This one's a little bit scarier, but it's really not that bad. Option number 2, and the preferred method by myself, which the book actually doesn't for some reason show, is multiply both the numerator and the denominator by the LCD of all fractions combined. You guys know how to find the LCD. We talked about that already. So we just need, yes, the potluck idea. We need to find the LCD of those 4 individual smaller fractions. And once we find that, we'll multiply it to the top and bottom of the larger fraction, which allows us to distribute in to all of the fractions. So really what I'm doing in the large scheme of things is taking the LCD and multiplying it to the numerators of every individual fraction. Now when I multiply the top, the numerator of those individuals by the LCD, all the numerators, gone. And you'll be left with just a normal fraction with a top and bottom, or a numerator or denominator. All the rest of it just disappears. So it's good to go. So it's kind of like a one-step process versus what your book wants you to do. The book wants you to take the top fractions, combine them by getting a common denominator, take the bottoms, combine those to get a common denominator, and then flip and multiply. That's at least 3 steps with simplification. I'd rather do it in 2 steps, find an LCD, multiply, simplify. I guess it's still 3 in a way, but it's a lot less of the nitty-gritty stuff. So, let's find the LCD. What is the LCT of this problem? First of all, are they all factored in a way? So remember, you got to factor all of those denominators, like x squared. Do we need to write down x squared as factored? What would that be anyway? X times x. Can you guys realize or recognize that x squared means x times x? Okay. Okay, so all the rest of them, there's nothing really to be factored. Now when we say factor, remember, if you saw something like x squared minus 9, oh, that's the difference of squares. That'd be an x plus 3 and an x minus 3. So those things are the ones that you'd have to kind of factor out to make sure you get the factors. So the first one always gets to bring everything, right? And then I'm going to go to the next guy. Underneath the B is an x. Does he get to bring that x?
Yes.
No. It's already been brought. M wants to bring x squared. Can he? No, because someone else is already bringing both of the x's, yes? It's kind of weird. It's getting awkward. They're bringing their x's. And K wants to bring an x?
No.
No. Can he bring a c?
Yeah.
Yes. So therefore, my LCD is going to be an x squared c. You guys okay with that? Okay. Now, I'm not going to have enough room. Well, I can show this first step. What is happening? This is how I want you guys to do your multiplication. It says multiply both the numerator and the denominator by the LCD. This is the larger fraction. So it's going to make more sense if you write it as x squared over c over 1 over x squared c over 1. And then what I'll do is I'll put parentheses around the larger or the smaller combined fraction of the top and bottom. Now the reason is that I put it as x squared c over 1 is because x squared c over 1 is just x squared c. I'm doing it to the top and the bottom, yes?
Yeah.
So technically I'm dividing the exact same thing to itself, which makes 1. And if I multiply something by 1, does it change it?
No.
No. So this is a legal action. Mathematically, legal, we're good to go. The reason I like to put the 1s in the bottom, it kind of acts like a placeholder. Because what I'm really doing is I'm only multiplying that x squared c to the numerators of the smaller fractions. So by putting the 1 underneath is allowing me to consciously make sure that I am always to the tops. The 1 is going to get carried to the bottom, and 1 again times something is just that thing. But here's the cool thing. As I'm distributing this through, like x squared c times a over x squared, what goes on? What's going to happen? The x squareds cancel. And so what am I left with? An AC. The a that's already there and the c that's left over. Plus multiplying it to the b over x. Now what happens? One of the x's cancel. So like all of this left, all of that left. But this one only cancels with one of those x's. So it'd be b, c, x. Can you guys agree with that? Under normal circumstances, for my LCD, I probably would put the c in front of the x squared. Because I want to keep things in alphabetical order. Okay? Is everybody okay with what I have so far? Okay. All over. Now we're going to the bottom. What's going to cancel? Right. Keep one x because an x only cancels one of the x squareds parts. One of the x's of x squared. Now the bottom. What cancels? X squareds with the x squared. So you're left with? Or we're going to say CM. Alphabetical order. It doesn't matter, right? It won't matter. Multiplication is commutable, right? So you can go in any order. And what cancels here?
One X and a C.
One of the x's and a c. So it's kx. Do we have a complex fraction anymore? Can I simplify this anymore?
No.
Yeah,
How?
the C's cancel.
C's cannot cancel. I can pull a c off the top. Because c's in both of them. I can factor that out. But can I pull a c out of the bottom?
No.
I can't factor it because the kx does not have a c. So therefore, I am done.
So you can leave it like that,
You can leave it like this.
and you can also take out a C.
You could write it as c times a plus bx all over cm plus kx.
There's no point to that.
That would just kind of show that you're able to factor it off, but at this point you can't do anything with it. Because that's the only thing you can pull out of any of those. Right. Okay? Of course, they go deeper into complex fractions. Now we have what I'm going to call a nestled fraction within a complex fraction. That m over b plus c over d part is a complex fraction in its own right, but that's within its own fraction, larger fraction. So now it's starting to get a little bit more complicated. So in these particular problems, to make your life a little easier, is that when you have more than one complex fraction nestled within another complex fraction, work your way inside out. So in this case, I'm going to multiply by the LCD twice. And that LCD will change from one step to the other. So in this case, I am going to just work on that piece. The m over the b plus c over d. I'm going to work from the most inside complex fraction, simplify that, and then move out. Okay? The LCD of that little part is what? What's the only denominator in there? D. Wait, why is it only D? What's underneath M?
BC,
No.
just B.
It's 1.
Why?
Because, if you notice, this here is the larger fraction of that complex fraction. It's supposed to be M over 1 over B over 1 plus C over D. You seeing that now? Guys, any whole number or variable can be written over 1. So it sets up, this is why we have the complex fraction. And that's why the only denominator is a 1 and a D. And 1s don't matter, right? So D is our LCD. And now I'm going to multiply that to the top and bottom. I pulled that inner fraction out. This is here. No. The X over the A plus part, we have not touched. That is still going to be there. That's here. Right now, I am working on that piece right there. Does everybody see that? You got to look at it to see it. So, I multiply it by D over D. So I get dm over, as I distribute, BD plus C. That is the non-complex fraction that needs to go in that space. But by placing that there, it makes it a complex fraction still. I'm going to take this one out to give myself more room. Now, looking at those 3 individual pieces in the larger one, what is the LCD? The LD is BD plus C. It's the only denominator. And so I'm going to multiply that to the tops, right? So it becomes BD plus C over 1. BD plus C over 1. These look complicated. We're saying, oh, it's not a complex fraction anymore, but it has a whole bunch of variables, Mr. Konchak. It does, but there's no fractions within fractions. What happens when I multiply across the top there in the numerators? Is anything going to cancel? No. And since the whole idea is to simplify things, am I really going to distribute the X to the BD and the C? No. I'll leave them separate. Because that overall is really what's happening, right? The bottom, am I going to really distribute the A again? No. So leave it separate. A times, okay, plus, what happens with those BD plus C's? So you're left with DM. Done. Abstract equations. Abstract equations, guys, that have limited numbers with multiple variables. So everything that's still applied to solving a normal equation still apply here. We have an equal sign. So the biggest rule is what you do to one side, you do to the other. And that's the important rule. It's like the golden rule of math, right? When we're solving equations. This particular problem wants you to solve for C. But where is C? On the bottom of the farthest fraction. So as long as we don't have complex fractions in our answer, we're going to be okay to solve for C. Now, I think there's a lot of us, they're going to say, hey, wait a minute, isn't that just V over 1? And then I could multiply or distribute that v in. So you guys have AV over X plus BV over MC. Will you guys be okay with that? That's mathematically correct, yes? Some of you guys will do that. Some of you guys will get the right answer by doing that. But you guys, that's a lot more work than I would say. Is V C? No. So get rid of it. As in, get it away from C. What's the easiest way to get rid of a V times a group? Divide by V, or multiply by its reciprocal. I'm going to multiply, guys, both sides by 1 over V. So what does the left side become? Y over V equals, the V's cancel, A over X plus B over MC. If you want to solve for C, do I need anything that does not have C's in it there? I want to solve for C. The only thing that's important to me at this point is the fraction that has C in it, right? So what should I do with the other stuff?
Leave it up.
Get it to the other side. So therefore, subtract the A over X from both sides. That will cancel them. So therefore I get Y over V minus A over X equals B over MC. Multiply both sides by? Yes, this one's interesting. I just want to get the C by itself. But when I solve for C, is the C supposed to be like 1 over C?
Do you do these problems alone?
No, I want to get C by itself on top. It needs to be in the numerator. So I could multiply both sides by C. Just get C out from the bottom now. Right? So now we get C times the quantity, and I'm not going to distribute here. We'll see why. Equals what? B over M. Get C by itself, I do what? Yeah, divide by the stuff that we don't want. Oh my goodness. What? It just set up a complex fraction, but hey, you guys know how to handle that. So all of this will obviously cancel each other. Now you got B over M all over Y over V minus 8 over X. What is the LCD to all of that? M, V, and X. Everybody gets to bring their own supplies, their own dip to the party. Okay? Now, guys, go back to what we did here. I'm going to go back. Look at these problems. What did I actually do with that x squared c? I multiplied it eventually to all of the pieces, right? So if I go back here, what am I going to multiply the mvx to? Top and bottom, or to all of the individual fractions, right? mvx, mvx, mvx. And therefore, if I do this, it's easier for me to maybe visualize things canceling out. Like the one with the b over m, what cancels? The m's cancel. What cancels on the next one? V's and the... And you write what's left over. A b, a v, and an x. What's left over? M, x, y, minus a, m, v. Oh wait, I forgot. Before I do that, equals c. C is equal to all of that because we canceled out all the stuff on the left there, leaving C by itself. So, again, we've got to solve for L. L is inside the set of parentheses, so anything on the outside can just be gotten rid of right away, right?
I thought we were
The
supposed
3 over 2t. So how do we get rid of a 3 over 2t?
to 2 over 3.
Not subtract it, but multiply it by 2t over 3. So that's kind of nice. On the left-hand side, the 3's will cancel. This and this will cancel, so then we got rid of all of that. So we're left with 2st equals 8d over L. I'm going to make that a capital L, I guess. We'll make it easier for us. Okay. 3's here canceled. Then, what do? Again, I only want L.
You add 3m.
Add the 3m over d. So I am left with 2st plus 3m over d is equal to 8d over L. Multiply by L. This one's actually pretty straightforward, isn't it? At least I hope so. So L times 2st plus 3m over d equals 8d. And so, last step.
She just said the bad, a 4-letter acronym that's not foil.
He's never enough.
Left side will cancel out, so L is equal to 8d over 2st plus 3m over
Wait,
A, or is that a D?
why did you just? Oh, never mind.
Oh man, we can't have that. I thought we were done. But that actually makes a
Complex fraction.
complex fraction. But here's the cool thing. The LCD of this thing is just D. So I'm going to multiply the top by T. I'm going to multiply this one by D. And I'm going to multiply this one by D. Yes? Multiply everything by D. So L is equal to 8D squared over 2DST plus 3M. Boom. Homework is on page 125, 4 through 9, 11, and 24. Have a fantastic day.